So we will be dealing here with the most popular type of energy. Okay, so this will be involved in a lot of industries in producing products. This will be applicable also in the oil and gas industry. In the I think everything, most of the processes involves heat. Okay, even metabolism, human body metabolism involves also heat. Okay, so in the burning of calories, in the process of regulation of heat instead of something like that. Okay, so as what I remembered, fats will be used as a fuel to convert heat, and then inside our body, and then it will be conducting, what we call as catabolism. Okay, the breaking down of larger molecules to smaller molecules. Meaning to say, from macromolecules to micromolecules, and this will be a lot of broken digested fats, toxins, whatever electrolytes that will come out in our body during our workout, exercise like that. Okay, so heat is involved also. So this is very popular and heat energy. Okay, so every examinations will always have this type of question. Okay, like that. Whether it is in elementary science, okay, in engineering science, like that, or whatever, name it, it will be at least included in different type of examinations. I'll give a heat, guys, because it's very popular. HEAT. Okay? The negative heat and the positive heat. Wow. Okay? Now, before going further, guys, because it is very, very common that usually problems like that involves really pure substances normally. For example, water, air, ice, gas, okay, ammonia, like that, carbon dioxide, pure substances, like that. So it's only rare to deal with, organic compound in doing this kind of problems. But still have, but you need to do first the rapid oxidation of an hydrocarbon or a fuel, or let's say you will be able to do the combustion process first before computing the heat energy or something like that. Diba? Okay? You have to determine its individual heat content of an element, of a compound, like that. Heat content meaning the enthalpy of each compound. Or we call that in chemical engineering enthalpy heat of formation, like that. Okay? And it's the heat enthalpy of formation of the products is equal to ganun. Okay? Enthalpy of heat content of the reactant, ganun, di ba? Okay, I don't have to expand further, ha? Because that would be complex already. I need to go to the basic, okay? So, for example, when I was in college, I always remember one constant. One constant or two, something like that. Okay, so I always remember the specific capacity of water, and I need to memorize the one only because I like one. It's easy to memorize, right? So specific heat or specific capacity. So we will call this as a CP, okay? Not cell phone, okay? Not centipoise in viscosity, but this is a specific heat capacity. CP ang atong symbol, like that. Or somebody will call this a specific heat only. It will do specific heat, and then sometimes also it will be used as a heat capacity only. The terms. But the appropriate term for that is really specific heat capacity, sometimes called as specific heat, and sometimes called as the heat capacity. But the symbol is Cp. Okay? Now, I always memorize this value because it's very easy to memorize. So 1 calorie gram degree Celsius. This one is the specific heat capacity standard of water. Okay? At room or ambient temperature 25 degrees Celsius. Okay, sometimes it's a little bit of confusing, right? Because that's why it's okay and it's very, very good to express, okay, and to, what do you call this one? To emphasize really the value of temperature in a problem. Because sometimes what makes it, tricky, because some problems don't mention the specific temperature. It will just be like this at standard temperature, and we don't know really yet what is the standard temperature because as what I researched, that is from 20 to 25 degrees Celsius. Okay? Okay. Now we treat standard temperature will be equal to 25 degrees Celsius. And sometimes also other problems in different questions will also say room temperature. And we don't know what is really the room temperature because it will vary, right? Okay, they will just assume that this is the value that we will be using every time in solving the problem. Okay, so if they say room temperature, it must be 20 degrees Celsius. Okay, and if it is ambient temperature, it will also 25 degrees Celsius. Okay, that's why for me, it's really good to state the temperature because it depends on the, our comprehension level. Okay, what I understand, if the problem will say room temperature, we will be using 20 degrees Celsius immediately without question. Mapugusta. Okay? And then if it is ambient temperature, that is equal to standard temperature, which is the 25 degrees Celsius. That's why we say from 20 to 25 degrees Celsius, the range. Okay? It will never be below 20, it will never be above 25, something like that. What I mean is that it's really, really good to have a specified temperature rather than, having it as an understood already. Okay? You get the point? Understood na siya. 25 na siya. Ganun. So, the interpretations are so many. Okay? Like that. It depends on the individual na lang talaga siya. But for me, ako na lang na siya memorize. If 25 degrees Celsius, standard or ambient. If it is room temperature, that is 20. Okay? 20 degrees Celsius. But anyhow, it will also raise to up to something like that to 21 to 23. So, di-assume na doon siya ng 20. Di ba? Kaloka. Okay? Yun na the point. So, wala siya kalimatan. Standard temperature, 25 degrees Celsius. Ambient temperature, 25 degrees Celsius. And the room temperature generally or understood to be 20 degrees Celsius. But actually, it will change on the weather condition, right? But in the purpose of problem solving only, that's remain 20, ganun lang siya. Okay? Basis lang ba? Okay? Ganun guys. Diba? Okay. So now we go to the conversion. So I have memorized also the 540 something chuba chuchu. 540, ano sabi ko siya, calorie per, per kilogram or gram. Something like that. Then I know in my brain cells that I have 540, and I will start with calorie gram degree Celsius, and we can convert that if our memory fails. My memory fails this time too early in my vlog, right? So 2,260 kilojoules per mole. This is the standard. But I am not perfect with a unit. Because, sometimes your memory fails. Like, I have to convert this starting from 1 calorie gram degree Celsius because this is very sure. Okay? Like that. Okay, how can I convert this to kilojoules per mole? And how can I convert this to calorie per gram, eliminating the degree Celsius? And these are all specific capacity and the latent heat of vaporization. Ganon. Basta wala ka na siya yung mga Celsius, guys, sa denominator, it's gonna be the latent heat of vaporization. Okay, if you are dealing with evaporation. At the point, a change from liquid phase to vapor phase. So that's the time we will use this. And your medium or your pure substance will be water. Okay, and the reverse is the latent heat of condensation. Okay? Ganon. But this 1 calorie gram degree Celsius, guys, maugin niya siya ang iyang specific capacity whether it is undergoing a condensation, evaporation, like that for in case of water. It will never change the specific capacity. Okay? But for the latent heat of condensation and latent heat evaporation. So this will be used interchangeably. Okay, the negative sign will be the condensation and the positive will be the evaporation. But these are all kanisha heat content. Okay, heat content and heat energy. Why? Because there's a presence of calorie, kilojoules at the top. And this is the unit of energy. Okay? Calorie, kilocalorie, kilojoules is the unit of energy. And then you will put only heat because, okay, you heat the water. Okay? And all substances have heat by itself, whether it is not being heated yet or heated up. Okay, because the heat in chemistry is not only focusing that there's really a heat existing na mo kuan siya ba reborn atong kuan, skin or whatever. Even though if it is a lower temperature, it's also considered as heat in chemistry. Okay, that is a negative heat, negative values. Okay? Noon, like a positive heat, tag-as o temperature, negative values will be the cold. Okay, sa negative, negative, o 7 degrees Celsius, negative 1 degrees Celsius, negative 2. And the heat positive will be going up, right? So it's boiling in the water, blah, blah, blah. So all are positives. Yun ang positive heat. Sorry, nasakit akong baba, ganyan, di ba? Ang negative heat mo na ang cold. Okay, less than 0 degrees Celsius. Okay? Very cold. Mo freeze na ang kuan, water. Mo freeze. Okay? So dili, di ba bugnaw gyapon mga 1 degrees Celsius, 2 degrees Celsius. Bugnaw lang gyapon imong mabati because that is positive heat, but at the same time it's also heat. So what I mean, heat is not applicable to higher temperature only. It's also applicable to lower temperature heat pa din siya. But very negative values kind of heat. So sa'yo tayo yung tanong, ang heat init rigid siya, okay? So because all cold possess also heat, but at a very, very lower level. You get the point? So atong usgon, let's revise and modify our concept when we say about heat. Okay? It's not all about positive heat, okay, that will produce burning like that, through burning, through pyrolysis or whatever. There's also heat through cryogenic processes. Cryogenic meaning refrigeration process. Okay? For example, we put water inside the refrigerator, it will become solid. There's also heat there. Okay, but the heat is very, 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 very small. Something like that. Okay? Nga, nawala siya, ni-overcome ang coldness. Ganon. So, ni-freeze na yun siya. O, diba? Ganon. Now, atong kuha ang mga values sa haon atong go harder kay gamit man kayo sa pag-compute sa heat. Guys, di ba? Because this standard will be used anytime because di ba natay formula nga kuan. Uy, based on sa akong mga stock knowledge ha, I don't prepare because you know, when I woke up, oh my gosh, there's a paper inside beside my, you know, bed and I have to solve some problems now. Okay, so Q is equals to the most popular bunog gani siya nga formula, MCPDT. Okay? So sometimes guys, other works using delta T or the change in temperature. And then the other also is using only the MCPDT. DT only siya. Okay? DT. The D, the small dt here, meaning to say the derivative or the change of temperature from final temperature to initial temperature. But some problems only don't have initial and final. Automatic that the temperature is given is always the T. You know the problem because there's talking a lot of changes. You will feel the problem really as you go over when you read it. That there is a transition of phases. That's why you will apply the DT, derivative final temperature to initial temperature. But if the problem doesn't involve like that, ayaw pugsa. Okay? Something like that. You got the point? So, marong tayo. So we will be in error if we try to force just to follow the literal values formula of QMCPDT. It depends on the problems you are dealing with. Okay? Like that's very clear, right? Because they will modify anytime the problems. Okay? Like that. So, Q is equals to MCPDT. And then if you are dealing now with, for example, latent heat of vaporization. Actually, guys, the heat of vaporization is just equals to latent heat of vaporization. Don't be confused. Puno-puno rin ang word na latent. But actually, it's just the same. Okay? Like that. Naputik formula ngayon ni aning ang formula. So Q is equals to the number of moles and then times the heat of vaporization or the, I will say LV. But actually guys, in the books, there's another symbol of latent heat of vaporization, ha? Ang uban HV, ganun chuchu. Okay? So, me, I will just have L from the word latent, the first letter of latent. But I will just also change this to H. It depends on you kasi nakasabot ang jud ka. Got the point? If you really understand the terminology and the concept, then any letters will do. It's not really an issue, okay? For us, okay, engineering students or chemistry students, whatever. Okay, so HV siya. Okay? HV na lang siya. Okay, para dali. And sometimes also, we have Q is equals to MHD also, latent heat of vaporization. And then this is for the heat. And for the coldness, okay, negative heat or the coldness, we have Q is equals to NH. Ano naman siya? Condensation. Okay, bali naman siya. Okay? The gas condense into liquid. That's why condensation. So it will become HC. Okay, then Q and HC. Okay, normally lower values of heat or negative values of heat. Okay, cold man siya. Right? Okay, ganon. Now, laoy, atong i-convert ang 1 calorie gram degree Celsius as our standard value of specific heat capacity. But may inom sa kong coffee. Charot! Ganun ba yun? I think so. Char! Wala dyan ako nanunduman guys, ha? Okay. Now, sige. Char! So, 1 calorie gram degree Celsius. Kaya kung ano pa man na siya, i-convert na siya chuba-chuchuk. So, 1 calorie gram degree Celsius. And now, if we are dealing with heat guys and energy chuba-chuchu, we need to understand the values of calorie to joules. Okay? Always, all the time like this. These are all units of energies, right? So we have 1 calorie is equal to 4,184 joules, right? Unit of energy. Ganon. Okay? Now, I have here 1 calorie, okay, and then I have here 4,184 joules. Cancel, so I have still the gram. So I want this to become 2,260 kilojoules per ganon, okay, kilojoules per kilogram or gram na siya. Basta, I have this value 2,260, but I forgot the unit. That's why I start with calorie gram degree Celsius to make this like this so that my 2,260 unit will be perfect. That's why I have the basis of 1 calorie per gram. Because my memory fails for this value of 2,260, either kilojoules per gram or either kilojoules per kilogram like that. But I doubt this is kilojoules per gram. Okay, because gram is the unit. But let's check. We convert, ha? Okay? Ganon. So, itong conversion natin, chuchu. Ganon. So, now, ganon siya, diba? Or it could be 2,260 also kilojoules per mole. For every 1 mole of water under standard condition. Pwede sabihan ko siya kilojoules per gram or kilojoules per kilogram. Kaya magdaog naman dito sa numerator, God. Hit ang numerator. And then the denominator, chuba-chuba, mag-cancel ka dito sa mga molecular weight baron, sa stoichiometric relationship. Mawala na yun ang ubos ang denominator na mahabilin ang unit sa energy. Yan na ang style. Okay? Always yun nga na ang style. Either sa stoichiometric relationship, dito ka magkuhan sa theoretical number of moles in i-balance ang chemical equation. Okay? If the problems involve chemical reactions, if phase changes lang siya, wala siya. For example, liquid to gas, H2OL to H2O. Kasi this is only a change. Phase of change is not a chemical reaction. So it's not an issue the number of moles there. The issue here will be the molecular weight, something like that, okay, or the molar mass. But if it is a chemical reaction, for example, if you split or decompose water into hydrogen gas and oxygen gas, so that's the time you will be able to determine the stoichiometric number of moles in your dimensional analysis solving of problem. Okay? Muna siya pa nasabtan yun na to, okay? Okay, that's the point here. And then, nakalimut man ko no. So I have to go back. So 1 calorie cancel. Okay, ganon. So I have 1,000 grams. Okay, is equals to 1 kilogram. Oh, muhulong lang sa kadiri-ari para makanselin mo ang grams, makanselin mo ang grams. Ganon, di ba? So, pila may value. Ato i-divide sa calculator. Okay? Calculator, please. Daghan mo kayo, guys. I mean, a lot of standard mga siya, guys, sa science. Purtidyo daghan. A lot of constant memorization in science. Okay? We cannot memorize everything. Others will be derived. Others will be found in the handbook during the examination. Okay? Ang dali nga memorize. So, i-memorize ang lisod and attack. Okay? Diba? Diba naman talaga yan. Okay, so 4184 times 1,000, ganon chuba-chuchu, ganon. Okay, so ganon siya. So, ang mabili na ng higayon na, muna siya, makanselin mo ang kuan. Kilojoules na siya, ato yung kilojoules. So, 1,000 joules. Okay, 1 kilojoule. So, ang mabili na ng higayon na will be joules kilogram. Para lang dyan mo jive dito sa atong value na atong gustong kuhaon. Okay? So, we are doing here a proving analysis of the standard, another standard. We prove if it is correct that 2,260 kilojoules per gram, 2,260 kilojoules per mole, 2,260 kilojoules per gram. Because I forgot the exact unit of measurement. That's why I need to prove something like that. Okay? Before going further. Okay? Like that. Now, in my equation, charat, okay, ang habilin kilojoules per kilogram. So let's show this. Basta na yung value na 2,260 kilojoules per gram or kilojoules per kilogram or kilojoules per mole. I don't know really exactly what is the unit. That is my problem, but I have the figure. Okay? Ganon. Okay. Huwag mo lang alam. Charot! On the spot. Okay, so it's gonna be like this. So, if I will have 4,001 for ganon, chuba-chuchu. Okay. And then divided by 1,000. Okay. So, na-apply ko an 4,184. Okay, 4,184 times 1,000. Review. Review din nyo guys ha. Nga naman dyan na siya. So, kung ma-confuse, i-review din nyo ang values. Wala, lagi kayo niya siya na anak. Okay? Bro, ka magdua-dua sa imong mind during examination. Okay? Lang, nakakaloka. So, makancel man niya siyang 1,000. No, ana na lang. Kaya pariho man, taas ang ubos. Pwede rin kami mo gamit o calculator, kailangan na pariho. Okay? Cancel ang 1,000. Sa algebra, guys, if pariho ang number, pariho ang unit, cancel siya kung nasa denominator sa numerator. Para di maglabad ng ulo, during the, sa calculator ba. Okay? At least ma-simplify na siya. Simplification of, terms and expressions. Charot. Okay, ganun siya. Now, unsa man yung inihigayon na? Now, guys, ang atong answer ni inihigayon na, guys, is 4,184. Okay? Joules. Ano? You will use your brain cells. Okay, brain cells talaga. Okay? That there are still degrees Celsius here na habilin. You got the point? Celsius nga nahabilin. Sa amin mo anong higayon na. Okay, mana din ka Kelvin to Celsius na po siya imong wato ni ini. Okay? So sa amin mo. So for na kay nabilin nga kuan Celsius imo na i-cancel ang degree Celsius, guys. Okay? Para mawala siya sa equation. Kung saan man mo. Okay? Muna imo yung kuan. Ganon. Okay. So, di ba? Napaka-Celsius, no? So, dapat di mo na siya i-convert sa Celsius para mawala po na siya, di ba? Get the point? Ano mo ang formula sa Celsius na po ka sa kuan? Okay, Celsius, ganon. Kelvin is equals to, Kelvin is equals to Celsius plus 273. Ganon. And then, Celsius is equals to 5/9. Di ba ganon siya? Then, 5/9 degrees Fahrenheit minus 32. Okay? Fahrenheit is equals to 9/5. Di ba? Ganon. 9/5 degrees Celsius plus 32. Okay, these three equations of temperature, or four, you should memorize this while you are still in high school. You get the point? So that it will be stuck in your knowledge in the college. Like that, it will never be it will be not washed away in your brain cells. No. So, like that. So, just like this, I still memorize the four formulas of temperature without referring to the book. Because I memorized that when I was in high school. Okay? So, sa saan pa na siya grumble, I can compute the values of temperature whatever units. Okay, so Rankine is equals to 1.8 times degrees Fahrenheit. These are all the four formulas of temperature. Okay, ganon siya. Okay, imong tiwanan guys, that degrees Fahrenheit, dako gila siya per imong kuhaan. Dako siya per day. So, may natin ka nga, Fahrenheit minus 32. Okay, nga may ka Celsius. Okay. Ang ibig ka Fahrenheit, imo na lang siyang kuan, plasan ang Celsius, kay gamay man ang Celsius. Ana ba? Ang factor ana per ni 5/9 baron, 9/5. And then ang Fahrenheit, kay dako man na. So ang 9 yung numerator, na imo na i-memorize. Okay? Nakibawa man ka ang 9/5 is 1.8. Pwede na sa nanaon mo 1.8 ang pag-memorize. Imo na siyang balingon, 5 divided by mga 0.5 something. Hindi mo ko ganahan. Okay, that's why when I was in high school, I prefer to use the fraction in my brain cells, not the point something. Inaanag ko ana until college. Na akong gamiton per ni 9/5, 5/9, dili ang mga 1.8 chuba-chuchu, nga 0.5 chuba-chuchu, kay maglibog man ko kay na point something. You get the point? So ganahan kong fraction, kaya dili naman siya cancel ang denominator to something. Diba? 5/9 multiplied by 9, cancel the 9, 5 ang nagbilin. Kung ay lubog sa point something. Okay? And the reverse also will hold through. 9/5 times 5. Cancel ang 5. 9 ang nabilin. 5/9 times 9. 5 dapat ang nabilin. So, dito kayo siya dua-dua if you will memorize that fraction, not the point something. You get the point? During memorization. Okay, so memorize this, guys. If you're listening right now, senior high school student, chemistry students, if you wish to study engineering courses or chemical engineering or basic chemistry, i-memorize na natin ang formula sa temperature. Dali naman kayo na siya, upatra na siya per ni. Okay, degrees Celsius, degrees Fahrenheit, Kelvin, and Rankine. Rankine is not common because it's an English unit. But it will also come up in the examinations in the future. Rankine and then Kelvin is popular. It's always applied in the ideal gas laws or ideal gas equations. Ganon. Kelvin has no degree. Take note. The only different for this four is the Kelvin. There's no degrees. Walay circle sa tumuwi of these four temperature formulas. Okay? So memorize now. Okay? Erase na ako ha. Ganon. So, I have now here, ang mabili ng higayuna is, kilojoules per kilogram, right? Ganon. Wala rin ka, hala, 0 degrees Celsius, how much Kelvin is this? Wala rin ka. So, 273 lagi ako na siya. Okay, kay 0 naman yung Celsius, hindi atrabi ito siya. Okay, the Celsius is equal to, Kelvin is equal to degrees Celsius plus 273 niya. 0 man yung Celsius. So, that's why it will become 273 ang Kelvin. Muna siya standard for me ang Kelvin. Ang 273 Kelvin is always the standard values of all gases and blah 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 so on in organic liquids. Okay, zero ng temperature nga gitreat sa standard sa STP. Sa ideal gas lang na siya ha. But dito sa mga lain na ng mga topics dito sa mga inorganic, organic 25 baya siya. Ayun kumpiyansa. Kaya standard dito 25 degrees Celsius. Sa STP rin dito sa ideal gas katong mga 0 degrees Celsius pag yung kuan values. Okay? Sometimes good ma-mix up kausahay. Sometimes mga sa mga problems. Sometimes in the ideal solution of a liquid. Ganon, ideality sa liquid na siya, bali sa gas. No, imuling makulik sa inyong mind, ang standard dito sa gas, lain man, sa temperature 0 degrees Celsius, baya, at STP, dito sa Avogadro law, right? Itong ingon ka nga, 22.414 liters of gas unoccupy at an ideal gas of 1 mole of air. Ganon. But dito sa liquid, dili na siya ma-apply. Kaya yung standard temperature dito kay 25 man. 25 degrees Celsius. So, yung kilbilahi na 25 plus 273. Especially dito sa topic sa katong mga kuan, katong mga enthalpy, katong mga heat content of different substances. Heat content ba? Because all chemicals have its heat content at standard condition. Kasi wala pa rin mo siya heat mo na ganyan yung standard na values. Okay? Ganon. Get the point. Wala siya. Pwede ka maglibog. Okay? Muna siya. So, cancel ka darat. Okay, so, pakailig decision kindaraan siya. So, ito rin i-convert din na siya. Now, mag-reaction ka. Why? Guys, kung wala ka nila yung choice, guys, na, layo rin dyan ang itong pag-prove. Layo rin ang itong pag-prove ba? So, we need to consider the balance equation. Okay, muna ang rules sa balance equation. Nasa purpose why your teachers in chemistry are always discussing to you like that because it will be happening again over and over again during your derivation, during your proving analysis, comparative analysis, solving of problems. It will come back again and again and again. Ito sa purpose, right? Like that. So, mubalik ta atong erase this ha. Ato na itong isud sa atong brain cells, ng mga formulas. Okay? So in knowledge retention, there are also sometimes, guys, when you're just listening to your instructors and teachers, sometimes nagsuwat siya, di ba? Okay, inikasuwat niya, mo register it in your brain. Okay? So this is what we call as, sabi siya, IQ, right? Yung pilit things in your brain ba? Kasi if the teacher and instructors will write anything in the board, even though if you will not write in the notebook or in the paper, it will reflect it in your brain. So that would be an added advantage. Okay, because it will save your paper, something like that. You are just listening and seeing, and then it will just automatically register in your brain. So if you have a gift like that, that would be better. Okay, something like that. Okay, because sometimes there are things that basahon rin galing makuha din jud mo pa. And there are also students also how many times they read it, they cannot still register in the brain. So, sometimes it matters on how you absorb quickly the lesson. But God did not give us like that always intelligence, right? So there are types of students that are weak, strong, average, and then that's why we need to educate and to teach what is really the proper way of absorbing and extracting the knowledge applicable to all audiences, whether what level of intelligence is that. Okay? Para patas. You got the point? Okay, kaya uban magsuwat pa dyan, ang uban dili na, kaya nasunas ng utok ang anak. Okay, so we go back now. So, okay, wala naman tayo mahimo. Wala naman tayo kuan, 4,184 kilojoules, diba, ana-ana? Okay, ganon-ganon. Okay, ito naman ang i-convert this, no? Okay, so ang saan itong buhaton na ani? Atong balhiman din ang atong equation para kung ang gawin kayo kung bolo, hindi ko matakbaw, in fairness. I think I need to have a very wide, whiteboard so that I can explain too much. Nakakaloka. Okay, so balik ko sa uno ha, sa mga kaloka. Okay. Di ba guys, anak siya. Okay? Laon, hurot akong coffee. Uy, mag-coffee ka ninyo. Okay, mga igalan, ikaw na dyan ko sliced bread. Wow. Kaloka. Mura na ako breakfast. Sliced bread with mayonnaise. O, di ba? Nasaan ito ko mga mga sandata. Char. Sandata. Magkuha sa okay, shout out ni Teacher Neoomuceno and other napkins. Thank you so much for passing by. Oh my gosh. What's happening? Oh, sa inyong pagtanaw ng higayunan. Okay? I will be mixing with English and Bisaya. In my discussion. I don't have to speak in Tagalog, sorry. Nasapit ako nila. Yes. Ang tawag nun? Mabubulol. And then matigas. The way because I am Bisaya, matigas. Dahil ang akong mga Tagalog, okay? So, very obvious that I'm really a Cebuano. Okay? So, I will rather speak in English and a mixture of Bisaya talaga siya. Okay? Nakakaloka. Okay? Uy, saan na to siya guys? Okay, mabalik lang sa taha para klaro. Okay? Ganon. Okay. So, 1 calorie, gram, degree Celsius. Ay, saan na hindi maklaro eh. Okay, times 1 calorie, 4,184 joules. Cancel the calorie. And then, 1,000 joules. Okay. Is equals to 1 kilojoule, right? Cancel the joule. Anak siya. Okay. Muna na siya tabo, no? Okay. And then, cancel ko rin na to ang grams. Lagyan mo klaro eh. Ano ni? Bati. Bati siya. Hindi ko ganahan kayo sa kaloka. Diba, mga palangga? Naluloka ba kayo mga palangga? Wait. Ako lang pala ang naluloka. Okay? 1,000. Maklaro na siya. Fairness. Okay. Gram. O, kaniklaro. 1 kilogram. O, diba? Cancel ang gram. Ang habilin kay kilojoules per kilogram. So, klaro kayo. Makancel yung mga 1,000 food. Ang mahabilin 4,184. Okay. Namuna siya, no? Muna na siya ang atong specific heat capacity in terms of kilojoules per kilogram degree Celsius. Okay. Now, I have no other choice. Okay, is to use the balanced chemical equation of the conversion, the synthesis or the combination reaction of water. Synthesis. Synthesis ganit guys, combination reaction na pagyapo na siya, ha? Okay, you have to synthesize man, so you have to add different elemental constituents to produce a compound. Something like that. Okay? So I have hydrogen gas. Okay? Plus oxygen gas. Okay? This is my question before I posted in Facebook and nobody got the correct answer. Okay? Like this. I will tell you. So this is showing how powerful really the Lord God in everything. Because we have science, right? Science is discovered by different scientists and they're very brilliant, right? And there are times in their lives that they cannot do anything. Because it's really God who made it appear to be like that. And they cannot explain more. You get the point? And they will bow down, and He did everything. But still, they cannot perfectly justify all their discoveries. Okay? Perfectly. Then they will say, only God can do it. Okay? So this is the example of the chemical reaction that the scientists are really surrendered. You know, really surrendered na talaga siya. Wala na silang magagawa. So, why? Because I will tell you. Okay? So of all the chemical reactions all over the world, trillions of chemical reaction, I found out in my own research, not ko sa kauling research, no? Okay, I have my own independent research by myself. Charot! Okay, so like this, so, see, H2 gas, di ba, in chemistry, science, right? If you add oxygen plus liquid, either the product will be liquid or a gas, right? If you add solid and solid, obviously your product is a solid because you don't heat it, so there's no change in phase, right? And then this water is very amazing. Why? God gave gas plus gas. And then when we produce liquid, nobody can perfectly answer this. This is impossible. How can a gas plus gas will become a liquid? In fact, your reactants are all gases. Now explain, all chemists, engineers, scientists all over the world, why? So this is an example that God is more powerful than everybody in this world. This is magic automatically. And imagine we drink the water, and that is all gases. You get the point? Hydrogen gas plus oxygen gas is equals to the liquid water. Why two gases will become liquid? Right? Actually, this is magic. Okay? But God do this freely to us in our planet Earth. There's ocean, lake, rain, river, any sources body of water, sea. So, meaning to say, God is powerful all over the world rather than those scientists or what we call atheists. Atheists are those people that will not believe in religion or they will not believe in God. And some scientists also are atheists. No religion, no specific religion, because they believe only by themselves because of their scientific discoveries that make them perfect, something like that. Atheist, A-T-H-E-I-E-S, something like that. I forgot the spelling. Okay, di ba? Ako na siya akong gipost sa Facebook and nobody got the correct answer. Okay, because I tell which chemical reactions that if you add two gases will produce liquid? Right. There's no other thing. Tell me, any kind of reactions in the laboratory that will produce liquid if you add gas and gas. There's nothing, right? So this is the example that very amazing that God gave to us. Hydrogen gas plus oxygen gas is equal to the liquid water. Now going back to the topic, I'm just emphasizing this. Okay? So we have 4,184 kilojoules per kilogram liters. Now, okay, this is not it balanced, right? Okay. Normally, under normal circumstances, nobody will say, minum sa kong water, kina-balance ang chemical reaction. Hindi naman ito yung ana, di ba? So, this is the siya nga water. Okay, like that. So, 2H2O2, di balance mo siya, charara, H2O, ganon. Oxygen 2, oxygen, ganon. Tararat, ito, ganon. Ito lang nato kasi yun naman kayo. Okay, so 2, so 4, so 2. So 4 hydrogen, 4 oxygen, so ganon siya. Ang oxygen mo 2, da? 4 hydrogen, 4 hydrogen, oxygen 2, oxygen 2. Ganon balance. So 2 moles of water na get siya ng higayon na. Okay, ganon. Now, 4,184 man siya, no? Hinaaman tayo moles dali ari. So, ano yung pagkuhanan niya? Okay, ano yun? So, 4,000. So, magsugod sa ka sa, di ba sa pang itudlo ninyo? Molecular weight sakta. Molecular weight. O, ganon. O sa unit sa molecular weight, mga palangga, grams per mole. Okay, di ba natin mo yung higayuna? Di ba? Sa ubos. Okay. Nang stoichiometric sa balancing equation, nasa tayo 2 moles. Okay, ganon. 2 moles of water. Okay. Kalit-kalit din ako, guys. Okay. Ganon. Na magpili ka ng higayon na asa ang imong i-use as a conversion factor. Para lang ni siya mahimong 2,260 nga standard nga akong na-memorize. Wala ko kibaw sa unit. O, diba? Sumali ko. 4,184 kilojoules. Okay? Kilogram, degree, Celsius. Kaya guys, ang kanitang molecular weight, gram na siya. Mubalik na sa grams. Hindi mo siya parang ka magdua-dua ba? Okay, so times 1 kilogram. Eh, para makuha lang hindi mo ang moles. Diba? O 1 kilogram, 1,000 grams. Unya guys, ang grams na dyan sa ubus, i-multiply sa mo ang grams na matuas at taas. So meaning to say, you will reverse the molecular weight. So that makancel lang yung GD. So that you can cancel the gram. Right? So nanagay kayo mo chuba-chuchu. Okay. So managay ka. Water. Oh, based on our memorization, the molecular weight of water is 18.016. Okay? Muna siya ang molecular weight sa water. So ano na yun? 18.016. Ganun-ganun chuba-chuchu. Okay, 18.016 okay, grams per mole. Ganon. So, cancel lang yung kilogram. Okay, kilogram. Makancel yung gram. Makancel yung gram. So, ang mabilin, kilojoules per mole. Okay, wala siya mabilin natin. Mani. Okay, calculator please. Igamit first ang molecular weight. Then, later na lang siyang 2 moles sa stoichiometric chemical reaction of water. Okay. Then, pasa guys. Ato sa aninawag ng char. So, 4,184 times 18.016. Gano'n chuba-chuchu. Okay. So, divided by 1,000. O, muna siya ang answer. 75.4. So 75.4 kilojoules. Basta na siya? 75 kilojoules per mole. So dili na siya mao. Kaya 75.4 man. Layo ra sa 2,260. Okay? Dili na siya mao. Get the point? Nakuha ninyo? Oh, mana siya. Now, kung gamitan din na ito, mole ang usa. Okay, na-arin natin sa reaction sa usa. So, 4,184. So, 75.4 kilojoules per mole ha. Kimani, mga palangga. Okay? 75.4 kilojoules per mole. Oh, ganun-ganon. Diba? Now, nanapog kayo molecular weight, di ba? Nakuha na namin mo. Ano din ka sa 2 moles. Okay? Naman kay 2 moles of water, so imo na siya i-multiply diretso. 75.4 times 2. Makancel ang mo sa mga kay kilojoules times 2. Okay? So, muna ni imong heat 1.50.75 kilojoules is the heat involved in the production of water from H2 to O2. So 150.75 kilojoules ang imong energy. Heat energy. Para mo-convert lang yun para mo-produce lang yung water. O, di ba? So muna siya. So naghinanglan ka 150.75 kilojoules para makainom na pag tubig. Okay? Na normal. You got the point? Muna siya. Grabe halaan yung nakakaloka. Okay? Muna siya, di ba? Okay. Now, nakakuha naman ka 4,184 kilojoules over, ito siya, gram ito siya, no? Oh, gano'n na yan. Okay. Now, imo na siya ihimong joules na pod. So, 1 kilojoules, 1,000 joules, and then, okay, 1,000 grams, gano'n, over 1 kilogram. O, diba? So, cancel ang kilogram. Okay, cancel ang grams, joules, kilojoules. Kung mabiling joules na food. O, diba? Nakakaloka. So, muna siya may tabo kang higayon na. Okay? And that's very clear. Okay. So, muna siya. So, 1,000, okay, 4,184 Ato sa nang papasok guys, gamay lagi kay kong board, hindi ko ka-expand. Char! Di ba? Hindi ko ka-expand sa akong ano ba? Akong buot nga ipasabot. Char! Okay. Muna siya tayo pasagaysan. Okay? Di ba? Ana. So, ano na nini mo? Na kay mga standard nga 1 calorie per gram degree Celsius. Yung mausad ni ang 540 calorie per gram. Okay? Yung nasa 75.4, di ba? 75.4 kilojoules per mole. So, muna siya yung mga standard. Okay? Like that. Ito the point. Okay. So, kay gusto jud ka magkuha og grams, usaw man nimo ning higayon na. Di ba? Usaw man nimo ning higayon na. Okay? Ibalitok nimo dili ang molecular weight diri sa 75.4. Okay? So ano na lang na nimo? So 1 kilojoules is equals to 1,000 joules. O, di ba? O, ganon. O niya, ang molecular weight nimo, kuan lang to, 18.016. Niya, ang mole, matuwad na po ang mole ato sa taas. So, 18.016. Ganon, gram. Cancel the mole, ang mabilin, joules per gram. Mapila mo siya. Para mahimo na sa siyang joules per gram. Ano, di ba? Okay. Ato na sa namin siya ituwad. Actually, mo naman ginagawa mo, tuloy ko ba yung siya guys, sa makuha lang hindi mo gano'n. Di ba? Yan sa taas. Ano na siya? Divided by 18.016. Nakay 4,185.16 kilo, no, kasi joules per gram. Okay? Yan. Okay? Ganon. Muna din siya yung other values sa joules per gram. 4,185.16, 540 calorie per gram, calorie gram per session. Muna yung gamitan guys ha. Later, I will be showing you a problem. Okay? Like that. Muna siya. Okay? Any questions so far? Sa atong mga concepts na ginagamit. Hindi makuha naman na siya guys. Hindi ka solve na nimo, di ba? Oh, diba? Ganun lang. Okay, see you later for the second vlog. Okay? Diba?